Shh. Hello, thank you for joining this webinar. It's on best practices, how to deploy good Wi-Fi. I'm your presenter, Gabriel Reyes. I'm a sales engineer here at Ingenious Technologies. All right, so let's do a little bit of housekeeping first, go over the agenda. We have a lot to cover. I want to make sure that we are able to answer a lot of your questions. So we're going to go over partner benefits at first, and then we're going to explore why to do a site survey, what is a site survey in the pre-sales aspect of it, what's a site survey in the post-sales aspect of it, and when to perform a site survey, and indoor best practices rules. And then we're going to set up an access point for you, an indoor access point, show you some of the best practices, how to configure it in our devices. And then we're going to go over some outdoor best practices rules, and then we're going to demonstrate how to set it up on an outdoor access point. We're going to go over some summaries, and then we'll have some questions and answers to that. All right, first we're going to go over the partner program. If you guys are not taking advantage of the partner program, I highly suggest that you do. There's a lot of great benefits in there, such as the free network design tools of Wi-Fi Planner. There's sales and marketing tools in there. There's a channel advantage. You get greater discounts the more that you purchase from us. Access to dedicated support team, the numbers available there on the partner portal. Certification and training programs, access to videos such as the one you're seeing right now. So a lot of great content. We're always adding more. So I would suggest that you actually visit partners.ingenioustech.com to start learning to earn. All right, so let's start with why perform a site survey. Okay, in the life cycle of a Wi-Fi network, this would actually be like the preamble. In this case, what you're doing in this stage is you're actually determining what the real goal or expectations or requirements are for the client. Most clients are not very technical, and most of the refreshes of our Wi-Fi are done every 3 to 5 years. So this will be this will be like a once in a very long time experience for the customer. And since you do it all day long, it would not be new for you, so you're viewed as the expert. So it's important that when they say something, you have to ask the proper questions to get what they really want. For example, if I were to ask customers, hey, what do you want the Wi-Fi network to do? A lot of common responses, hey, I just want Wi-Fi everywhere. So based upon that, if I was an inexperienced Wi-Fi designer, I would say, okay, well, you're looking for a coverage-based design, right? So less number of APs, higher output power, place them, just get you signal, because signal is easy, capacity is hard, and at that particular thing, I'll give you that wireless network. Let's say they never told me they wanted other things on the network, such as voice over Wi-Fi calling or barcode scanners or anything real time. All of a sudden, when they start trying to put that load on the network, it's going to have a higher chance of failure. And all of a sudden, that network is not going to be working for them. And so I'll have to redesign the network in the planner to make it work for what they have. So it's very important here to actually get the proper requirements, also set the right expectations. I call it the least performing, most important client or application, LCPI. So basically, if they're looking for roaming for cell phones, I would design a network for that. Obviously, that type of network would be not appropriate for a roaming for a laptop. So it's important to choose what the most important client and application is, design the network around that, and everyone else would come along for the ride. And certain things that you design for one is going to break another. Make sure that's properly explained to the customer so the right expectations are set. Also, one thing to determine if the client should be hired or not, you think a kind of a weird bullet point to go over, but it's important in this aspect. And most of the time, if you look at your profitability, where your profit comes from, about 80% of your profits will come from about 20% of your customers. So it's important that you properly qualify the customers, just like you would if you qualify an employee that works for you, because they're going to be determining your bottom line. So obviously you don't want customers that are going to be calling you every time there's a minor hiccup, or obviously you don't want another customer that's going to call you after 3 months of experiencing a problem and never notifying you and expect you to fix it within 30 minutes. So obviously you want to make sure you properly find the right spectrum of those customers and the right number of them so you could drive your profitability in that regard. Purposeful site survey will help you practice good Wi-Fi rules. Just like with anything in life, If you practice a lot of it, it'll become second nature. It's important that when you do practice, you practice the proper rules. If you're practicing in the improper rules, you'll be very perfect at doing things wrong. So you want to make sure that you are practicing so you can always be doing the right things. And remember, once the network loads exceeds the network capacity, the quality of your experience has a higher chance not to meet the customer expectations. So let's take this out of the technical realm into something that's much more palatable. Let's say, for example, I had a bridge made of popsicle sticks I glued together. Okay, well, I could expect that to be carrying a load of maybe some toy cars. But it's unreasonable of me and improper of me to expect that to be carrying a load of a full-scale large semi-truck. Same thing for a Wi-Fi network. If I design it for one aspect and another aspect's loaded onto there, I should not be expecting that to be working. And that needs to be properly conveyed to the customer as well for their right expectations. So what is a site survey? A little bit of rework. Don't want to do plagiarism, but the definition on Wikipedia would be the process of planning and designing a wireless network that will provide a wireless solution that will deliver the required requirements. My addition is to reasonable customer expectations. I know it sounds like a lot, but basically the shorthand of it is, hey, the whole purpose of doing the pre-staging or surveying is to actually make sure the wireless network is going to meet the customer expectations. So you're going to make sure that you solidify the requirements, making sure that it's exactly what they want, and making sure what they don't want is important as well. In this case, also, you're not 70% of your time will be spent in this stage, in the planning stage. Obviously, the life of a Wi-Fi network is not to scale because the planning should take a majority of the portion of it. So, for example, if I had 30 days to plan, design, deploy, optimize a wireless network, I would be spending 21 of those days in the planning stage. Now, in the planning stage, we're not just going to be basically thinking about how things are going to be done. We're actually going to be doing things to make sure that most of our time will be spent when we actually deploy, to be deployed, as opposed to troubleshooting, or in the troubleshooting stage for optimization. So things to be looking out for is to be figuring out the most important network requirements in the wireless clients, choosing the right AP model for performance and features, choosing the right number of APs, location of the APs, configuration of the APs, number of switches, configuration of switches, cable types, number of cable runs, how to accomplish those cable runs, obviously choosing the right gateway or router and the configuration of that, and a proof of concept of this as well. You want to make sure that for networks that are very important, you want to make sure that you have a small scale proof of concept deployment. So when you deploy at large scale, you should know how it should look like, how it should work. Important things for that are network baselining. Network baselining we have two ones to go. We have wired and wireless, because basically a wireless is a portal to the wired network, so you make sure you baseline both of those aspects. For wired metrics, obviously the top network users would be important. Maybe that metric may not be important in certain verticals. For example, if I'm in a hotel, I have lots of clients coming in and out, and they're unique clients. It's very hard to have a set predictable rate of clients are going to come in and out. But in an office environment, that's very easy to do. Peak time is important. When's the network being loaded the most? Total node count, how many people are actually on the network? Type of traffic that's being sent on the network. Is it unicast? Is it multicast? Is it broadcast kind of traffic? The traffic vectors, the direction. Is it LAN to LAN traffic that I'm experiencing most of on my network? Is it LAN to WAN, which will be upload? Is it WAN to LAN, which will be download type of traffic? All that is very, very important when designing your network, just because you want to be sure that you have something quantifiable, so that when you actually do any changes or do set any configuration changes on it, you actually would have a metric to determine whether it's helping or hurting the network in achieving your goals. For the top wireless metrics, similar to the wired for top users, peak times, also got other things to worry about, like AP density, wireless client count. What are the signal strengths of the client to the access point, and vice versa, if you could see that information. And also the physical the physical layer as well, like channel utilization and airtime utilization is very important for the health of the wireless network. So what is a site survey? What's a post-sale site survey? Well, a post-sale site survey is basically after you deploy, you need to make sure that you do this stage to be optimizing. Basically, you want to validate the results of what you have planned. If planned correctly, this stage will be optimizing the network. If planned incorrectly, the activities will be troubleshooting the network. So that's the reason why you have to develop the right plan so that you spend most of your time in this stage just validating optimization as opposed to troubleshooting. So when to perform a site survey, I would deploy it before I deploy a network, after I deploy a network, as well as when I'm coming in a network I didn't design, like troubleshooting type of scenarios. The reason why you want to do before and after is because if you're ever called for troubleshooting, it'd be a lot easier to troubleshoot if you know what it looks like when it's working and what it looks like in a non-working state. And the delta between that would be something you could develop a plan to troubleshoot with the metrics that you determine to look into. So this is helping you in order so you could troubleshoot less and be able to have more uptime. So let's go over some of the indoor best practices rules. Before we go over this, we have to talk about some basic things, such as why using 20 megahertz channels in 2.4 is ideal over 40 megahertz channels. Well, as you can see in the top, if I use 20 megahertz channels, I have 3 non-overlapping channels, 1, 6, and 11. If I choose a 40 megahertz channel in 2.4 gigahertz, I really only have 2 channels to choose from as opposed to 3. And one of them is going to be 40, one of them is going to be 20, and so the amount of data that's able to be pushed around across those cells are going to be different. So in one cell, I may be able to have higher throughput, another cell maybe have lower throughput, and that's not going to be an ideal design. So in the 5 gigahertz space, we have many channels to choose from. If we do 20 megahertz channels for non-DFS, we have about 9 channels to choose from. If your client doesn't support channel 165, it'll actually be 8 non-overlapping channels. The reason why this is important is because bare minimum number of channels in order for proper channelization is 4. 2.4, you have 3. So we have to do some kind of design techniques in order to try to avoid or to properly channelize to avoid co-channel interference in that one. In 5 gigahertz, the maximum channel width I would have for multiple AP deployment is 40 megahertz because it gives me 4 non-overlapping channels. That'll be the bare minimum I need for proper channelization. And you can see if I do 80 megahertz, I get 2 non-overlapping channels in non-DFS. And if I do 160 megahertz, there's really no spectrum available that's not going to touch the DFS. And the DFS channels are going to be 52 to 144. But why am I spending so much time talking about the DFS in this regard? Well, DFS channels is important to understand the limitations and where to use them, where appropriate to use them, and where not to use them, particularly for indoor and outdoor deployments. For indoor deployments, DFS is used if you run out of channels to choose from, if you have a higher number of AP densities, or if you want to be able to have more proper channel separation in areas in which roaming is not really a requirement. For example, if I'm in an area where, like a lecture hall, in which people are going to be filing in and sitting as a stationary location for longer than a minute or 2 or 3, DFS channel may be appropriate to use inside, as opposed to one that's a static one. Channel, non-DFS. So FCC requires us that if I have a DFS event, I vacate the channel for about 60 minutes. Some channels require higher levels of caution than others. For example, channels 116 to 132. If I have a DFS event, I'm unsure whether it's a true DFS event or just some random RF interference in that particular time. FCC requires me 98% of the time for me to vacate that channel. If I was on maybe channel 64, it goes down to about 75%. So even the channels within DFS determines how sensitive it is to external noise that you have. Important things to know, the DFS channels cannot be actively probed like non-DFS channels, which means your roaming events are going to be slower. And after you deploy DFS, make sure you monitor the network for about 72 hours or a week or so, just to make sure you have no DFS events occurring. If you do, then you might want to change to another DFS channel that's less sensitive to noise, or move to a non-DFS channel. It's important when you do this, it's going to change your entire AP fabric channelization plan. So that's also important to take into account as well. So important things to consider is AP model, number of APs, physical location of APs, configuration of a single AP, and configuration of a system of APs. So for choice of AP model, you're going to look at things like wireless client density. For example, if I was deploying my access points in a ballroom as opposed to a cubicle farm, in which a majority of the stuff in the cube farm is hardwired and very light wireless usage, I would use maybe a 4x4 or an 8x8 access point there, as opposed to a 2x2 like I use in the cube farm. Wireless client capabilities. Let's say I'm deploying in an area in which they have a lot of high-end MacBook laptops, and that's the most important client they're going to be using. Well, okay, that means that the minimum access point I would be deploying is a 3x3 to match the client. So that would mean I would use a higher end access point for that particular type of deployment. Network load requirements. Let's say, for example, let's pick on email, for example. So let's say I have email and I have an on-prem email server. Okay, well then it's that type of traffic is not very latency sensitive, not very bandwidth intensive, doesn't have to be in real time. And that's great. And that means my packet loss could be up to 7 to 10%, and I won't experience any negative impact on that particular application. Well, let's say now I decide to move to Office 365. Okay, well that's off-prem email now. Now I got to take into account the latency and packet loss of a network I don't control, which is the internet. So now the requirements on my side of the network have to be more stringent in order for that application to survive. So same application, same switches, same cables, same clients, same access points, but I changed the application of traffic flow type. All of a sudden now that changes the behavior of the wireless network. So something that was behaving 7 to 10% packet loss is now only surviving with about 1 to 3%. So that's why we say application is very important for the driver of your wireless network. Integrated or connectorized antennas. Why would I show an outdoor antenna for an indoor slide? Well, some verticals require outdoor antennas for deployments, such as warehouses or areas that are not climate controlled, or workshops that have a lot of dust around, or barns or something. Things of that nature in which an indoor access point will be destroyed. You need to deploy an outdoor access point for that. And of course, the most important thing is budget. And budget is not just the total cost of the cost of the access point, just for MSRP. It's also the total cost of it. For example, if I had a 8x8 access point, that is a higher cost of the access point as well. It had to supply probably a better cable to go to it for higher density, for better power. Maybe upgrade my PoE switches to handle a bigger PoE budget to handle that access point. And maybe the cost of installing that's a little bit higher. So that's the true cost of an access point. So I also got to take the true cost of an access point in beyond just the cost of the access point itself. Then we have things to take into consideration, such as wireless client density, placement limitations, cable run limitations. Obviously, budget's important as well, and requirements such as roaming. That's obviously going to determine the number of APs I choose. Environmental factors that determine the APs is environmental factors. For example, if I was deploying in close to an elevator motor shaft where they actually runs the motor for the elevators, maybe when the motor turns on, unintentional RF interference is occurred, and it also impacts not the wireless, but also the wired side as well. I have actually seen that before. And so those are kind of things you want to take into consideration when you're actually deploying it. The Wi-Fi network or your hardwired network of what to take consideration. Bad fluorescent light ballasts could cause problems. I've seen it before on exit signs or fluorescent lighting. Let's say metal ceilings. You obviously don't want to mount an access point directly to the metal ceiling because you'll get the same signal strength, you'll get less signal quality. And that's going to obviously impact the capacity of your network to carry a certain load. Physical network security concerns. Ideally, I want to mount the access point at waist level. But let's say I do a hotel deployment and I want to deploy it at waist level. Well, that's not the best way to do it because I have physical security concerns. Obviously, an access point deployed at that level would be more chance of having vandalism or theft. So due to that physical security requirements, I got to mount it like on the ceiling or in a lockbox, a plastic lockbox. Aesthetic concerns. I don't want people to see the access point. I need to be able to hide it in certain areas. Let's say I want it in a hotel room and deploy it inside the hotel room. I want to be able to put it behind an armoire or a bed or something that's not easily accessible so that people are not able to see it, but they're able to enjoy the benefits of it. Individual access point considerations are output power, wireless channel width, number of SSIDs. These will impact and many more will impact the performance of your wireless network as an individual cell, but you also need to take into account when deploying a large number of access points, how is that one channel configuration or one AP going to impact the entire network as a whole? So things such as output power planning, channelization, wireless channel width planning, number of SSIDs that I use for the entire network for application or wireless client base, number of 2.1 gigahertz radios turned off. For example, most of my deployments, about 75% of the 2.4 gigahertz radios are turned off on my access points. And that's true for many other people that design networks as well across different industries. Basic rate setting, you'll do that for particular reasons. For more high contention that will impact your association boundary, but if you need to be able to try to mitigate the contention base, you'll want to have a higher basic rate setting. For example, if I go to some hotels, I notice that their basic rates for 2.4 or 5 is set for 24 megabits a second, as opposed to, as you see here, 6 or 1 megabit a second. Other things to consider, PoE budgets of the switches. You want to make sure the switch has enough power to power on my access points. For example, the 8x8 access point is going to require more power than the 2x2. I need to make sure that the switch is capable of 802.3 AT or even higher than that if need be for the access point. Also, the number of port densities on the switch. If I have other things connecting, such as wired computers, IP phones, multifunction printers, I want to make, or POS systems, I want to make sure those have access to the network as well beyond the addition of the access points. Proper cable type for the deployment. Obviously, you want to make sure you're using the right cable so that so you actually get the best experience. For example, this in-wall, the label CMR, that would be solid cable. For the patch cable, the CM, general purpose cable, that would be mostly a stranded cable if I'm not powering anything off of that. Those are two different cable types. I'll use them for two different reasons. It's important to grab the right cable for not only indoors as well as outdoors as well. So let's do a demonstration on the indoor access point. Okay. So in this case, we're going to set up a 1300. So I'm going to log into the access point right now. And let's first start with some basic settings. First, I need to make sure it's on the proper subnet I want at the management. In this case, it is. I'm just missing some DNS information, so I will add the DNS information in here. So I'm adding Google Public DNS. In this case, once I'm done configuring, I'm going to scroll down and hit Save. Now, this is where a lot of people new to our products run into problems. There's two ways of actually applying the change. You go apply it down in the upper right-hand corner here, or you go click on Changes, and then click Apply in there. And it's going to reboot as it applies the changes. So these changes will be persistent. If I disconnect the power to the access point and reconnect the power again, those changes will be saved. If I didn't save these changes, then what will happen is that those changes are not going to be applied as I'm running it, as well as when I power cycle it, those changes are going to be lost. So it's important that we actually click Save and Apply for those changes to be applied to the access point. And this is true for all of our access points. So let it do the boot up process. It's booting up a lot of services on the access point right now. So let's start managing the wireless. So in this case, we want to be able to label this. Let's say we want to label this as the lobby AP so we could identify it easier. We would turn off green mode, which already turned off in this case, but if it comes default on, we would turn that off. We're going to set the proper channelization. In this case, I'll do 20 megahertz channels on both. Transmit power, I want to have a 6 dB off spread between 2.4 and 5, so I'll set 2.4 to 11, and I'll set 5 to 17 dBm. I also want to make sure that the proper SSIDs are here. Let's say I want something for the lobby. Let's say I have a production. And then let's say I have a guest. And let's say I have some kind of IoT device, like a thermostat or something. Most IoT devices 2.4, I'll do that. Guests, probably want to put them on 2.4. There's no real expectation of them to actually do anything important in production. I'll do that in 5 gigahertz. If need be, I could also do another SSID for production. In there, in which basically people that want to connect to my production network don't have 5 gigahertz because you know 2.4. Okay, let me do that. So let me hit save. And again, we can apply those changes, but we got a little bit more changes to do, so let's not apply those changes quite yet. You want to add security, let's click this edit button over here, and we're going to add some security to this SSID. Now you do the same for all SSIDs, I'm just going to do it for one, just for brevity's sake. Okay, let's do super secret password 1, 2, 3, 4, 5, 6, 7, 8. And you can see there's many other settings we can also change as well in this device. Okay, we're not quite done yet. Let's try the channelization now. So in this case, we're going to click the channel configuration here, and we get to choose the channel we want to set these devices at. So in this case, I'll do 1, 6, and 11. Maybe I'll do channel 6, and then for this I'll do 153, and maybe I would do like channel 149. Save those settings. Okay, now we can apply all those settings at once. That's the beauty of this, is that you could queue up your changes, and then you could set all those changes at one go. So long as they're in the proper type and proper order, it should be fine. For example, for green mode, if I disable green mode, there is some other stuff that I cannot change and won't be preserved after it comes from a reboot back from green mode. For example, when I uncheck green mode, I won't be able to see the full option of channels until I actually save it and apply it and it reboots. Then I'll have access to the full number of channels then. Okay, so that's how you would configure an indoor access point. So let's go back. All right, now we're going to do some outdoor best practices for the rules. So items to consider for your outdoor ones are going to be almost similar to indoor, as AP model, number of APs, physical locations of the access points, configuration of a single access point, configuration of a system of access points, as well as wireless bridging if need be. So AP model to choose, basically with our devices, you're able to do multiple modes of operations. It could be an access point or it could be a bridge. So it's important to know if you want an access point or a bridge in this case. The physical size of the device, you can see there's many different sizes that we have for our devices. As well, you got to take into consideration the antenna footprint as well. So if I were to get a connectorized type of access point, I also got to take into account the footprint of the antennas and what to do with them. Mounting feasibility. Sometimes these devices, maybe some devices you're only able to pole mount it. And so if that's a pole mount and I want to mount it to a hard surface, I would have to have a system in which I would mount a pole to a hard surface and then mount the device to that pole. Wireless client density. As you can see in the bottom right, we have an outdoor venue that has some contrast sometime. So obviously most outdoor deployments are not high density. In this case, you do have one that's higher density. You would choose the right access point in order to be servicing that base appropriately. IP rating, something you don't have to worry about for indoor access points. Basically, how well is it going to survive to the weather that I deployed out? And sometimes some access points have higher IP ratings than others. If I have a lower IP rating, I want to be able to do some type of modifications so to survive. Also, it's not listed here, but temperature ratings will take consideration. So if I were to mount something outside directly exposed to the elements and it gets really cold, you may have a shorter lifespan on that device or less performance than you anticipate. And obviously important for budget as well. So the number of APs that you choose determines upon factors such as the network load, whether you're a network load for bridging as well as client density. For example, in the top here, we see something we call throughput stacking. So as you go through the bridge, every single bridge is going to be an additive effect upon the throughput. So in this case, you want to make sure that your most latency sensitive device and the heaviest bandwidth device is closer to wherever you want it to be as opposed to further, because it's got to contend with other traffic as it goes through that for the bridge. Placement limitations on these devices. You sometimes can't place the outdoor access points where you would like them to be due to easements or mounting restrictions or things of that nature, or cable runs or access to power, which is all listed here as well as your budget. As seen, sometimes there's a MIMO box here that has power there, which can help out tremendously. And that will also increase the cost. Physical locations of the access point to take to environmental factors. For example, if I was doing a downtown area, I had a lot of street lighting, that was sodium vapor lighting. That's going to kill your 2.4. It's well known that sodium vapor will kill 2.4, as well as 5 if it's close enough. So if that was the case, I would make sure that there's a physical separation between those interfering devices in order for that to work. Attenuating materials, as you can see in the image, you have drywall and brick. Indoors, there's not going to be that much attenuation with drywall. With other things such as brick, you're going to have massive attenuation. Another thing that people don't consider is a new thing called E-rated windows. They're very good because they block a lot of RF radiation from the sun coming in, but they block a lot of RF radiation. So I'm physically able to see through the device, but according to the RF, it's equivalent to going through a brick wall. That's also one thing to take consideration as well. So that's why we always recommend, if you're going to be deploying Wi-Fi, don't try to do an external to internal penetration type of scenario for your network. I've seen a lot of motels do this. I've seen people that want to serve a garage 200 feet from the house. They want to put one device up to service that. That's not really the ideal way to be deploying that. And that's going to be leading to more chances of failing than actually being successful. So you want to make sure that you design appropriately. Physical security concerns, as same thing as you had in the hotel. You obviously wanted to make sure it's mounted high enough so that people can have access to it. But also, if you're going to be mounting higher, like you have to rent a boom, make sure that you have access to important infrastructure. For example, if I had PUE injectors that had reset buttons on them, well, I would mount the PUE injectors reset buttons lower that can reach it with the ladder, and I'll have to rent a boom, and the antennas could be up there with the boom. So the antennas get the physical protection, as well as the infrastructure I need to have access to reset it is also protection as well, because it's very unlikely someone will run around with a ladder and be resetting your access points. Also cable run limitations, and also it's important that you have the right cable type as well for outdoor deployments. The wrong cable will cause a premature failure. I also wanted other items to take into account is grounding requirements for outdoor access points. You will have voltage potential difference that you don't have to worry about for indoor deployments. You want to make sure that you ground appropriately for that. Proper use of shielded cables and connectors for outdoors so you could carry that transient current down to ground. The quality of the power. For example, we had someone deploy it in an RV park in Indiana, and a lot of the RVs had generators. They were inputting bad sine waves back into the power that was supplying the access points and causing them to have weird behaviors. It wasn't just us. They were replaced with another vendor that had the same problem. The other vendor was not able to identify the quality of power issue. We did identify it, and they did rectify it, and that did improve the quality of the uptime of that wireless network. If there's no access to power, you need solar power battery backup. Now, it's not just as easy as just grab a solar panel from Fry's and install it. You got to take some planning and consideration to there. What's the size of the panel, the quality of the panel? That all has got to go through some mathematical equations to determine what's the size you need, what part of the earth that you're going to be deployed it in, how much sun you're going to be getting. Battery backups are going to be, how big of battery backups you're going to need, how much equipment's going to be used for amp hours. All these are going to consideration for outdoor ones. You may need to use hardened PUE switches, which have a higher cost. Obviously, that's going to take into account for your deployment cost. And also, when you're doing things with RF cable or Ethernet cable, don't forget about drip loops and service loops. I've seen many times which people try to run a cable, and they run it from building to building, and there's no drip loop, and that water follows the cable all the way down into the wall and destroys the equipment behind there. So it's always important to have drip loops and service loops for deploying cables outdoors. So now we're going to do a demonstration on the outdoor ones. So this will be an outdoor one that we're doing. In this case, it's a dual band 620. So the same settings you have to worry about for the basic settings. In this case, the basic settings are set to the proper subnet with the proper DNS. We're going to go in here. We're going to try to configure the wireless. So in outdoor deployments, you see the green mode is actually enabled on this one. You got to disable green mode. Maybe name it so that you know which one it is. I would name this maybe Zone 1 AP if I mapped it out and put in the proper zone. 20 megahertz channels. I want to do a offset of 6 dB, but in this case, outdoors, I want to have a little bit higher power. So maybe 20 here. And then I want to make sure that I set the appropriate SSID. Let's say this is just an outdoor one, so I just only have to worry about guests. That's it. you know, and maybe just do guest, put that at 5 gigahertz, and just do guest 2. Make that 2.4 gigahertz. And then I'll save the changes. Now this is going to look a little bit different because I had disabled green mode, but all of the changes will have to be done in the two-part process which I showed you earlier for the settings to be persistent. After this, we'll do a little bit of a scan. We'll see what channels to place them on. We'll place them on the channels, and then we'll save those settings, and that's good to go for the outdoor access points. So yes, we're as you see, it's loading up right now. So also, it's important to note that the reason why we talk about pre-staging devices is because you don't want to be doing this when you're out there in the field. This obviously takes some time. So obviously, you want to spend the least amount of time deploying it and the most amount of time to be enjoying it. So in this case, what you want to do is you want to be sure to pre-stage before you go out, label them appropriately, and then when you deploy them, they'll be up and ready to go. You just hook them up, access the power, they automatically will connect, and then you just do some minor changes like channels or power output power here and there. As well as you also want to bring extra pieces of equipment. Sometimes you may run into some problems that's unanticipated, and extra equipment is going to be very helpful. So in this case, let's do AP detection. Let's just channelize in 2.4 first. And then the same thing will be done on 5 gigahertz. So the reason why I do 2.4 is because it's kind of a harder one to be deploying in. As you can see, there's all these different devices that we see that are deploying. We see signal strengths. Obviously, channel 6 is not a good channel to be deploying at. They have a really strong signal strength going on there. Channel 11, it seems like a little bit better. At channel 1, we have a certain device that's kind of bad there. So I would say probably the best of the worst choices would be channel 11. So let's go over here and let's do channel 11. Now let's assume we did the same thing for 5 gigahertz and we determined that channel 165 would be good for this one. Okay, as you can see, this is the two-part saving process. We have to click save on the bottom, and then we have to click apply either here or over here in changes to click apply in order for the settings to be persistent. And then when that comes up, the access point will be ready to go. Okay, let's go over some summaries. For indoor best practices summary, try to maintain a 6 dB spread between 2.4 and 5 gigahertz radio. Turn off the 2.4 gigahertz radio to prevent co-channel interference or co-channel contention. This may mean you have to turn off 75% of the APs with a 2.4 gigahertz radio disabled. You're still going to have 5 gigahertz on. I'm just going to disable 2.4. Do not deploy APs in hallways. Stagger APs vertically or horizontally when deploying APs. You don't want to stack them or put them in a straight line. You want to make sure there's a most amount of instructions between the access points and least amount of instructions between access point and clients. Use DFS channels in the right situations after fully understanding its drawbacks. This is for the 5 gigahertz. Ensure proper channelization. Ensure proper AP separation. You don't want to have two access points that are like 2 feet apart from each other. Pre-stage before deployment, it's important. If radio is beyond ladder reach for indoors, let's say I have a big atrium and I have to rent a boom, you want to make sure that those are going to be set and ready to go so that you spend the least amount of time renting that piece of equipment. Have extra equipment ready when deploying, as we stated before. Sometimes some stuff may happen, so you want to be able to have extra equipment ready to go. And make sure that you do your due diligence as is performing a site survey before and after the deployment. And you want to make sure you engineer a solution, not just hobble something together, such as the example of the popsicle bridge. Same thing for outdoor. You want to maintain a 6 dB spread between 2.4 and 5 as much as possible. The greater the spread, maybe a little bit better, depending. Use the smallest channel width you could get away with in outdoors. Use the lowest output power you could get away with. When using RF cables, use the shortest run that you could get away with, including the service loops and drip loops. Also, use the most appropriate frequency for bridging, given the line of sight requirements and distance and load of the network. That's for the bridging. Use DFS channels until you can't. So keep using those channels until you have an event, and then once you have an event, then that will tell you you can't use those channels anymore. Ensure proper frequency adjacency, just like you did with the indoor ones. Ensure proper antenna physical adjacencies. So if I had an antenna, dual band, let's say I have an 871, I have to get 2 antennas. So I want to make sure there's a proper separation of them. Make sure easement rights are going to be there when you mount the device. Sometimes you may not have that and you think you do, and that's going to really throw your plan off. Particularly in RV parks, we've seen that. Make sure that you have clean power located at the location, so you don't start trying to troubleshoot gremlins that are actually just power things. Pre-stage before deployment, just like we did for the indoor ones. Have extra equipment ready, and make sure you update the firmware before deploying these devices, and also deploy site survey before and after. That was a lot of great information. Now we're going to be doing the questions here. So first, let's start answering some questions, or answering some questions. Okay. So we have an attendee that's asking, are those Uni2 channels even displayed in the drop-down menus? Yes, it is. As we stated earlier, with green mode enabled, you're not going to have access to see the full lineup of the channel lineup at 5 gigahertz. Once you disable green mode and apply it, it goes to the reboot, then those channels will be available for you. Okay, it says, how does mounting against metal affect access points? Well, if you look at the MCS index, it doesn't say signal strength. It has a lot of different parameters, such as spatial streams, modulation, encoding, short guard interval, long guard interval, things of that nature. So what happens if an access point is close to metal is that when it transmits, it's going to have a lot of reflections. Now, you think that's good for MIMO, right? But the thing is, in order for MIMO to work, it has to be a multipath that's expected. Unexpected multipath will actually, at a certain point, will break down in MIMO. You get the same thing as you have for a 1x1. So you want to make sure that when you're mounting access points against metal, you do a standoff of about 2 to 3 feet. So try to get some more air attenuation so it doesn't have that impact on the access point. But that will reduce your number of spatial streams on the access point, thus reducing your efficiency on the network. Because when I talk about capacity of network, I'm not talking about user density. I'm actually talking about speed. In wireless network, capacity is all about speed. So the faster I get someone on and off, the quicker I can get someone else on, the more people I can add to there, and the better the network will be for everyone. So we also have another question that says, for production, why not same SSID for 2.4 and 5 gigahertz with band steering? It's a great question. There, we're doing best practices. You could deploy it in that way. It's just that you're leaving a lot of the roaming algorithms left up to the client. So a lot of people think that auto channel, auto power, airtime fairness, band steering, a lot of people think that's actually part of the standard because every vendor offers that. Well, the truth is that's not part of the standard. That's actually all vendor proprietary. So if you start designing something with more vendor proprietary layers, if you start running into unpredictable behaviors, you have to start removing those vendor proprietary layers and more go to standardized to start predicting the network, the behavior of the network. So it's important that when you deploy, these are best practices, so you could try to avoid as many problems as you can. So I prefer to actually have a separation of 2.4 and 5. It's a lot easier to determine which band you're having problems with. So for example, if someone says, hey, the Wi-Fi sucks, the question is, okay, which band are you having problems with? If you have the same SSID for both bands, it's hard to determine that. If you separate it out, it'll be a lot easier to determine that. Okay, we have another question is, what's the benefit of having separate SSID names for 2.4 and 5 instead of, we answered that. That's a great question, thank you for that. And another one says, if not hallway, where? Ideally, inside the rooms would be the best scenario there. So what is a DFS event? So a DFS event, basically the FCC says that if you determine a certain signature or certain strength, you have to vacate those channels because those channels could be used by other things such as navigation for aviation or Doppler weather radar. You don't really want to be stepping on that. So that's what the DFS event is. And once that occurs, it's going to automatically change the channel. And you can see that because the operation channel will be different than the configuration channel. And in the logs, you'll see a DFS event as well. That's a great question. Thank you for that. Another question is, why do you turn off 75% of the 2.4 gigahertz radios on APs? Well, here's the thing. A lot of other vendors, they have RRM, radio resource management. They can adaptively adjust the channel or the output power. But the only true way to really avoid co-channel interference is not turn down the power, is to actually turn off the radio altogether. That's the only true way to actually prevent co-channel interference. And since 2.4 gigahertz travels very far, you want to make sure that you have the least chance of having a co-channel event on that particular band. So you would turn off the 2.4 gigahertz radio. And most of my designs and other Wi-Fi designers and planners do for other vendors say on average, that's about the number they're seeing. About 75% of the Wi-Fi radios turn off for 2.4 in their designs. Because they're designing for 5 gigahertz. That's what we do nowadays. And that's a great question. Thank you for that. It says, could you go over the 6 dB spread again? I missed that part. Yes. So the 6 dB spread between 2.4 and 5 is so that 5 gigahertz would have almost similar coverage than 2.4 because 5 gigahertz actually it's a higher frequency. It's not going to effectively be as usable signal as far. I want to make sure that's said appropriately because a lot of people say 5 gigahertz doesn't go as far as 2.4. Physically, it does. If I were to send 2.4 or 5 gigahertz signal to the moon, they'll both hit the moon at the same time. They're both traveling at the speed of light. The things that impact it are, one, the frequency. So 5 gigahertz has a higher frequency, 2.4 is a lower frequency. So to conceptualize this, let's say I have 2 cars down 100 linear feet of road. I tell one car to do 100 turns, one car to do 20 turns. Well, at the end of that 100 linear feet, the one that did 100 turns has a higher odometer reading. Its path distance is dissimilar. And that's one reason why 5 gigahertz has less amplitude by the time it gets to the same linear space than 2.4. Another thing that goes into play is aperture. If you're ever dealing with cameras, aperture is the ability for it to capture particular light. In radio waves, antennas do have apertures, which is the physical capture space it has of the frequency. So higher frequencies have a smaller aperture than the lower frequencies. And so you have this effect of having a signal which has less amplitude by the time it reaches you, as well as you're able to see less of it because you have a smaller viewing window. And that's the reason why 5 gigahertz doesn't, I guess, quote unquote, go as far as 2.4, as I say, have a usable signal. I know it's a long explanation, but thank you for that question. It's a great question. Okay, when grouping access points, do you lose the ability to configure individual channels? Actually, no, you don't. If you go to the individual access point itself, there's an option for override group settings, and that's how you would override those settings to individually set those. And thank you for that. It's a great question. All right, so we have another question of what are considerations for mesh network requirements? Consideration is the application. I would only use mesh with the understanding that that particular application on there is not going to be latency sensitive or bandwidth intensive. If it is, I would highly advise you to not use mesh. I would look at another alternative like an indoor wireless bridging or power line Ethernet adapters, or you actually run the cable. But thank you, that's a great question. Another question is on the 5 gigahertz side, when I select channels 20, 40, 80, you said to choose 20. I find that when you do select 20, you don't get the highest speed throughput. That is correct. Based upon the MCS charts, if I do 20 megahertz channels, I don't have access to MCS 9 in certain spatial streams. And the reason why we're doing 20 over opposed to a fatter channel like 40 or 80 is because when you start doing fatter channels or wider channels, you need to be able to qualify the environment to make sure that that's appropriate to be using. Because I have seen cases in which someone has an 80 megahertz channel deployed, there's so much interference going on that I actually get less throughput than if I do it to 20. So in this case, you hit up against one of the rules of Wi-Fi is use the widest channel until you can't. So in this case, if you say 20 is too slow and you go to 40, it's faster, okay, well maybe 40 megahertz is proper for that environment instead of 20. And use that until you start getting negative impacts of latency or speed, and then you could drop down to 20. And that's a really great question, and thank you for that. Another question is why not channels 3 or 9 on 2.4? If we were to go back to that slide, you would see that that would be overlapping. So channel 3 would be overlapping with 1 or 6. 9 would be overlapping with 6 or 11. So you want to make sure that you don't do that. Now, is there cases where you would do that? You would bend the rules or a little bit break them? Yeah, you can if you understand what you're doing. These rules were designed for not for end-all be-all. They're designed to help you deploy a wireless network that will be surviving in a lot of different environments. But if you know that channel 3 or 9 is good to deploy at based because other access points are on other like 1, 6, or 11, but they're not going to be tripping your CS, then by all means, go ahead and deploy in those channels. Just understand that you are bending one of the rules and understand why you're doing it and what the consequences are of that. And thank you for that. It's a great question. Okay, another person says, does output power make a difference? Why do you need a 6 dB spread? I believe we explained this. Basically, the attenuation would be greater at 5 than 2.4 in the same linear distance due to the properties of the frequency of the wave. But thanks for that. It's a great question. Earl Clark, oh, sorry, we have another question that says, on 5 gigahertz, why is a 20 best choice? What will it take for 40 or 80 to be a better choice? You could get technically into this, saying, oh, here's the channelization, here's the airtime usage, here's the the retry rate, or you could just do a dead reckoning thing, just deploy it. And if you see you getting better throughput at 20 than 40, I would stick with 20. And that's a great question, and thank you for that. It goes to the other the same rule we talked about. Deploy fatter channels until you can. Okay, we have another question here. For hotel deployment, is it best to have multiple SSIDs on each access point versus one SSID? Lobby, first floor. Moreover, should we separate 2.4 and 5 SSID? Does this only help with troubleshooting? That's a great question. It doesn't only help with troubleshooting, it also helps with roaming. There's a lot of things that come into play. For example, 2.4, the last time we ever revised that in the standard was 2009. And so a lot of the things we have for roaming, like IL-11K and R and V, they're not going to be included into that as mandatory. It's optional. So you'll see that even the roaming behavior on a particular band would be different. So if I do band steering, all of a sudden the roaming behavior is predictable on one band, it goes to another band, and all of a sudden I can't predict the way it roams because that client doesn't have a particular amendment update that is available in the 5 gigahertz because that was a more up-to-date. So in this case, should you have multiple SSIDs for certain geographic areas? That's up to you whether you do want to or not. I like to do that for IoT devices because, for example, if I have a thermostat, I do not want the thermostat to be roaming. That's kind of what I don't want it to do. I want it to be on one particular access point that I know of. So in this case, I would produce a geographic SSID just for those devices so they don't roam around. And that's a really good question there, and thank you for that question. Okay, and another one is, can I daisy chain switches if I run out of power in a few devices? I would, no, you can't really do that. It's basically dependent upon what the switch can do. So in this case, you would have to, the better choice would be to actually get a switch with the bigger PoE budget. It's going to be more easier to deploy, and that money is going to be better spent. Because doing it the other way, you're going to be spending, you think you're going to be saving money, but you're actually going to be spending more money by trying to put together a design which is going to be suboptimal. So you're spending more of your time. And obviously time is money if you're an installer, so you want to be able to deploy something that you know is going to work as opposed to something that may or may not work. Okay, thank you for that question. That's actually a great question. And yes, there's a lot of great questions here. I would really love to answer them all. And via email, if you have more questions, you can email us to partners@agenusite.com. I'll be happy to answer them for you and point you in the right direction. Unfortunately, we have ran out of time, but thank you for your attendance. We really appreciate each and every one of you. And I want to thank you for your time.